In this lesson, we're going to program the SwissCam plug, and we're going to do it from the solid model. I'm going to go ahead and open up the job file, tools, cycles, and post. Here we can see we've got the completed file with the solid model and several windows for turning, y-axis milling, and index milling. I'll go ahead and click New Job. Now we can load up the incomplete tools database. So if we open up the tools file, I'm going to load up the tools database that's missing a few tools, as we'll create them during the process. And same with the cycles. Let's go ahead and open up the incomplete cycles. And I want a material for this job. Let's use stainless steel wrought. I'm going to import the solid model. I'm going to use the XT Parasolid. So here's my XT file, and we'll open it up. So the first thing that you'll notice here is our origin is oriented incorrectly, and it's also not at the origin where we're going to program our part. So let's go ahead and correct that. Do so, I'm going to use the edit part coordinate, and we're going to set the part origin to the arc circle center. I'm going to go ahead and pick an arc on the face of the part and go ahead and click set. So that now sets the origin to the face. Now we need to orient so that the z-axis is pointing away from the part. So the blue axis pointing away. So to do that, let's rotate around the X, the red axis, -90. So we're going to rotate the part, -90, click rotate. So there we are. Go ahead and click close. Now, if you wanted to program off of this part using a combination of the 2D and 3D, we can use extract turn geometry. We'll set the face plane, the boundaries, and it'll take sectional or spun geometry, which this will get projected into the 2D view. But I'm just going to go ahead and focus on programming as much as I can here directly off the solid. So I'm going to define the face plane. I'm not even going to worry about extracting geometry. And you'll notice my turning plane angle is set to 45 here. And this is important. If this was set to 0, you can see that the turning plane is going through this flat. So I won't get good geometry to turn through, as we want to make sure we're on the outermost diameter of this boss. So 45. And it's setting our boundaries in X and Z and our face plane. So I'll say OK. And now we can go into the setup dialog. So we're starting off as always with main spindle turning. And we've extracted the length of the part from the solid model and the OD, but now we want the OD of the stock, so we're going to use 1/2 inch stock. Solid bar, so no ID. The excess stock to clean up the end of the bar, 10 thousandths. And the guide bushing length and the guide bushing diameter, those defaults look okay. I'm going to call this window main turn. I'll go ahead and click close. Let's go ahead and create a profile. So we're contouring on the face of the part with just a finish pass. We'll go ahead and select the tool. Here I have tool number 2 in the gang. So I'm going to go ahead and select it. And I'm going to call this face and click close. So we get an automatic insert profile. I'll go ahead and verify this. Set the verification delay to 5 here. There you can see we face off the end of the part. I'll pick a new color, and now we've got some ID work to do here. So I'm going to create a new hole, and because we have the solid, I can extract the parameters directly from the solid. So you can see all of these elements get disabled because they're going to be extracted. We're prompted here to select the cylinder or cone, the diameter equal to the major hole diameter, and then click extract. The only things you can set here are the type and the face clearance, so we're going to use drilling, and 50 thousandths off the face will work. So I'll pick the hole. You can see the surface that highlights in red, and I'll go ahead and click extract. So you can see it finds a drill 120 thousandths. We don't have a matching cycle, so let's go ahead and create one. And we want 2 operations in this hole making cycle. So click insert operation, and we're going to spot drill, spot face. We always enter in the hole diameter that we're spotting. Now let's go ahead and select the tools. So we've got a spot drill, but it's in the back working station, so we want to add one in the end working station. 1/4 inch, add. It's carbide, end working, tool number 22, offset number 22, length 3/4 inch, shank size 1/4 inch, height 1/4 inch, and go ahead and click shape preview. Looks good. Go ahead and click OK. And now we need a drill, 120 thousandths. We don't have one, so go ahead and add it. Carbide, again end working, tool 23, offset 23. 3/4 length. Looks good. Say OK. So now we've assigned our tools. Click OK. And you can see here we don't have a chamfer, so the spot drill hasn't been assigned a depth. Let's go ahead and just take a look, and we can see what happens. Verify this. I'll slow this down to 9. So you can see it spots and drills, but the spot drill doesn't actually spot the part. It stops at the face. So we want it to go a bit deeper than that. So let's go ahead and edit the cycle and force an 80 thousandths depth on the spot drill. Go ahead and verify this again. There we go, that looks better. So now that we've drilled that out, we're going to go ahead and bore it. So I'll pick a new color, new profile. This time we're contouring on the inside of the part. Just taking a finish pass. Go ahead and select our tool. And we don't have any ID boring bars, so let's go ahead and add one. So PartMaker sets up our parameters. So we've got a boring bar, diamond insert, carbide, again in the end working station. This will be tool number 24, offset 24. The length here, 1.25 inches. The width is going to be 0.1. The shank, 0.08. And the inscribed circle on the insert, 0.06. We'll leave the included angle. Let's go ahead and set the nose radius to 2 thousandths. And I'm going to add a round shank to this. So we'll make the round shank 1 inch and the diameter of it the same as the shank size, 80 thousandths. I'm going to call this bore bar. Do a shape preview. So it looks good. And go ahead and click OK. So now we've assigned that tool. Call this process ID bore and click close. So now I'm going to define the profile on the solid. I'm using end snap. Let's go ahead and zoom in here. I'm going to start up at the top of the chamfer, come down, and to this point here. Let's go ahead and verify that. So it looks good, except anytime we do ID boring and we were to come in here, now we stop, the tool is left on the inside of the part. So it's possible we could call up a tool chains or something and make a move and break off the boring bar. So whenever we want to do a boring process, we want to make sure that the tool pulls out of the cavity. So the protocol for doing that is to go into the cutting point and tell PartMaker to return to the cutting point at the end of the cut. So go ahead and verify this again so we can see what happens. So we can see now we're returning to the cutting point. If you want to define a different point here, we can enter a custom point. So say 0.18 in X. Verify this again. There we go. So now our ID work is complete. We've got some OD work. Pick a new color, new profile, contouring out to the right. Just a finishing pass. Let's go ahead and select the tool. I'm going to use this turning tool number 2 in the gang. Call this turn front. I'll click close. Now I'm going to define my profile. I'm going to start the front, come up to the top. Now I want to come all the way to the back, so I'm going to use horizontal constraint, and I can pick one of these endpoints. Then we'll come up to this point here, and right to the top of the chamfer back here. I'll go ahead and verify. There's my turning process. Let's go ahead and show the stock here. So you can see we're just barely exiting the stock. Let's make our lead out a bit longer. Say 50. And go ahead and verify this again. That looks a bit better. And I'll turn my stock off. So now that I've turned that, I've only turned this far because we're going to come back to the front and do some threading, and we don't want to risk pulling the part of the guide bushing. So I'll turn the remainder after I've threaded the front. And before we thread it, we want to groove it to make a thread relief. So let's go ahead and make that groove. Grooving on the outside, just a rectangular groove. Select the tool. Here we've got a grooving tool, number 4 in the gang. Call this groove. Click close. Now for this one, I'm going to use chain geometry. Make sure when you're chaining geometry, you can see the orange line highlighting the direction that your chain will go. So when starting up here, make sure your mouse is slightly to the left so you're going the right direction for the chain. And we'll click one time and come to the end of the groove and click again. So you can see we chain through all of those points and we can verify. There's my groove. Next we're going to thread the part. So I'll pick a new color, create a new process, threading. On the outside with no chamfer, the in feed will be 5 thousandths, minimal in feed 1 thousandths. The pitch on this thread is going to be single lead, so 1 divided by the number of threads per inch. We could see here it's 1/4 28. So this number will be 1 divided by 28. Let's go ahead and select a tool. Here we have a threading tool, 60 degrees. We'll select it. As you can see, it pulls in the 60 degrees. PartMaker calculates typical thread height. Clearance is the clearance over top of the part as it makes our multiple passes to thread using constant volume removal. Acceleration distance. This is the distance in front. We want to make sure that the spindle can get up to speed, so we need to give it a bit of room. I'm going to copy and paste the pitch into here and do ×3, so 3 times the pitch. If I click apply, you can see that number calculates. We'll call this group thread and click close. Now I need to define the profile. So we've got a lot going on here, so let's go ahead and show work group only. Now I'm going to define the profile, and we're going to start out this first thread here, and then we're going to come back using mid snap and horizontal constraint. So if we come down to this point right here, middle of our thread relief, and go ahead and click. And I'm going to verify this. So there's our multi-pass threading. And I can click show all. I've got to turn the remainder of the part, so I'll pick another color. New profile group, contouring out to the right. Finishing tool, go ahead and select a tool, again number 2 in the gang. And when we lead out, I want to lead out 50 thousandths, 45 degrees. And we'll call this turn back and click close. I'll define my profile, end of an element, starting at the top of the chamfer. Using horizontal constraint, I'll come to the very back. And we can verify. Looks good. I'll pick another new color. So let's go ahead and cut the back of the part off here. Create a new group. Cut off. We're going to insert a chamfer. So we know the cutoff distance. It's been pulled from the part length. And the chamfer, you can see if I double click on the chamfer back here, it's 45 degrees 10 thousandths. So 10 thousandths. Since we're going to chamfer this, we're going to turn on the optional 1-2-1. Starting up at 1, plunging down the bottom of the chamfer, back up to 1, and then doing our chamfer cutoff. So go ahead and turn that on to rough out before we make our chamfered cutoff. Now the start point needs to be the radial value of the part, where right now it's of the stock. So if I double click on the part, you could see 240 is the radius. So I'm going to change this number to 0.24. And go ahead and select my tool. Number 1 in the gang, cut off. Call this process cut off and click close. You can see a cutoff's been inserted, and we can go ahead and verify. So now we've completed all the main spindle turning on this part. Next, we're going to make the slot on the face of the part. So to do that, we're going to do that with Y-axis milling. Make a new window, main spindle, and I'm going to mill in the ZY plane. We can pull the index angle directly off our part. In this case, it is going to be 0. I'm going to call this mill ZY and click close. So let's go ahead and set the face plane. We'll pick the bottom surface of the slot and go ahead and click Define Face. You can see here the offset is negative 20 thousandths, so the bottom of the slot is 20 thousandths below. Click OK. The slot itself, if I double click, you can see it sits 40 thousandths back. And if we wanted to measure any of this, we could use our ruler and see that the distance from here to here, this is 40 thousandths. So we're going to need a 40 thousandths slot saw. Make a new profile group. We're going to be contour milling to the left. The X surface and the depth. We're going to set that by extracting the parameters from the solid. So I'm going to pick a surface on here that I want the tool to clear over top of. So let's say this red surface here, and then I'm going to hold Shift and select the bottom. So when I click Extract, PartMaker sets the X surface to the highest surface and then calculates the depth, so the distance between these two surfaces. So that will put the bottom of the tool at 0.155 from 0.135, and those are radial values. Just going to make a finishing pass, and we want a 1/2 inch tool. Go ahead and select our tool. We want a slot mill. We don't have one, so go ahead and add it. This is going to be carbide in the gang slide. Tool number 10, offset 10, 3/4 of an inch, 1/2 inch diameter, 1/4 inch shank. The height here is going to be 40 thousandths. Number of flutes, 10. You can do a shape preview. Looks good. Now anytime you have a gang live tool, that tool has to sit back from the face of the gang. So from the center of the shank to the face of the gang, we have a tool shift. Now some machines you set the offset in the machine tool, other machines you set the offset by using a work shift like a G50 shift. So if you go to Tool Properties, here's where we can set our tool shift. So negative 1/2 of an inch. And if we want to output this shift as a G50, you can check this box. If you don't want to output it and you just want to see it correctly in simulation, you can uncheck this box. So let's say I'm going to output it. This will depend on your machine. Click OK. And I'm going to call this slot. Click Close. Now let's go ahead and define the profile. So I'm going to start here and go to this point here. I'll verify and click OK. There we go. If you've clicked in the wrong direction and you're getting a result like this, then you just need to reverse your profile. So select the profile and click reverse so you can make sure you're on the left side. I'm going to remove these lead in and lead out angles and radius. So we're just going to come straight across. So just leave the line length for both the lead in and the lead out. Now we'll go ahead and verify. Looks good. Next we have some flats to mill. So I'm also going to use the y-axis, but for this one we're going to use a different window. So make a new window on the main spindle, and we're going to use mill polygon here. So this will bidirectionally mill using a live gang tool, but now here you can see our work plane is going to be at the end of the part. So we're just going to draw the polygon, and PartMaker will take care of all the C indexing and Y moves. So I'm going to call this mill poly. Click close. And for this one, I'm going to use a mix of the 2D and 3D window. So I'm going to project into the 2D window. So another way we can set the face plane is if you double click, set face plane, and transfer planar geometry. So if I turn on my face plane, you can see that set the face plane back to that surface, and it's projected the geometry. We'll project with the rest of them. This time, set face plane doesn't need to be selected. Just double click, and the last one. Now we're going to create our polygon, so I'm going to go into CAD mode, and holding down Shift, I'm going to choose all 4 arcs and press the delete key. Now to reconstruct a polygon, one shortcut is use the fillet icon and just set the radius to 0 and click in the corners. Go back into CAM, and we'll go ahead and create our profile. So the distance from the face of the part, we'll extract this from the solid. So we'll choose the plane touching the tool edge. So right here, click extract. So it finds that the left tool edge will be 550 thousandths back. And I'm not going to adjust the X surface. We're at the outside of our part. Rapid and clearance, which is in this case above and beyond. You can see here R, and then C is cutting beyond. And the tool diameter. For this one, we're going to use a different size tool. Again, if I pick 2 points here using my ruler, we can see this is 200 thousandths wide. Use a slightly bigger tool, say 375 thousandths. Select the tool. We don't have an end mill of that size, so we'll add one. It's carbide in the gang slide. This will be tool number 7, offset 7. 0.75, 375, height ½ inch. Say it's 4 flutes. Set your tool shift for any gang live tools. And if you're going to output that, do a shape preview. Looks good. We'll say OK. And I'm going to call this process flats and click close. And here I'm going to use the chain geometry on the 2D and go ahead, just click on a corner, and we can verify. So there we are, milling the flats. Next we have some cross holes on the OD. So we're going to do some index machining. New face window. Again on the main spindle. For this one, mill diameter index. Call this diameter index. Click close. So we're going to set a cylindrical face plane here. So I'll choose the outside cylindrical surface, define the face plane. You can see it's going to grab the OD and set that for the face window. If I look at my face window, you can see it set that value for the OD, and it pulls out the correct circumference. Let's go ahead and create the process. I'm going to pick a different color here, say green. New hole. I'm going to extract from the solid. Choose the hole. Click extract. You can see our drill cycle finds all the parameters. We don't have one, so let's create a cycle. 2 operations. Spot drill, spot face. Enter the spot size for the hole. Select. So we don't have a spot drill. So let's create a spot drill, 1/4 inch. We'll add it. Carbide in the gang slide. This will be tool 8, offset 8. Length 3/4. Shank 1/4. Height 1/4. Shape preview. Looks good. And again, make sure if need be you set your tool shifts for gang live tools. Click OK. Now we need to create the drill. Carbide, gang, tool 9, offset 9. Again, make sure to set up your tool shifts for this tool. Shape preview, looks good. So now I've assigned the tools to these 2 processes. We'll click OK and close. Now I'm going to assign the part feature to the part. So I'm going to use chain holes and just pick one hole, and you can see it finds all of them. Go ahead and verify. Spots all of them and drills all of them. Last, we've got some back work, some indexed holes on the back end. So we're going to create a new window. This time, this is going to be done in the sub spindle, and it's mill end index. Call this end index. Click close. And we'll create new hole group. Again, extracting the parameters from the solid. Pick the hole. Click extract. And we don't have a drill cycle that works for this size, so we'll create one. We're going to spot drill, spot face, enter in the hole diameter, select the tool. Now we have a 125 spot drill in the back working station, tool number 41, so go ahead and select that. You can use that. We don't have a drill, so let's add the drill. Carbide. This will be back working. Tool 42, offset 42, 1 inch length. And the diameter and the axial step, which is defaulted to half the diameter. We're actually going to peck drill this, so if you wanted to adjust the peck depth, you could do that here. There's our drill. So I'm going to change this can cycle to deep hole because we're going to peck drill. Click OK. I'll click close, and now assign the part feature and go ahead and verify. So you can see we spot drill and peck drill. So now we've programmed all the features on this part. So let's go ahead and generate the process table. And we'll let PartMaker automatically move the cutoff to the end and eject the part after the last subspindle process. Turn on my time chart. So here are all our processes. And we want to synchronize. So I want to synchronize the sub work with the main work. The one issue we have here is we can't synchronize back working, you can see here in green, with end working in blue. The problem is the sub spindle must go over to the main spindle to do end work, but it has to go over to the back working station to do back work. So it can't be in two places at once. So we're going to need to synchronize the back working with the gang work here starting at P5. So process 5 is where we're going to start changing the mode switches. So here, while we're machining with one tool in the main, we're going to allow the sub to machine with one tool. And we'll do this for the remaining main spindle processes. So you can see all the mode switches change. And with the sub spindle, machining with one tool in the sub, and we're going to allow main spindle processes to occur. We'll do this for both of the sub spindle processes. If I click Sync Group, here you can see we've synchronized and taken basically care of all the weight codes or any other codes that need to go in for synchronization. The cutoff is actually a synchronous process too. So here, while we're cutting off on the main, we want to support with the sub, so follow support. And the distance that we want to grab up onto the part, so from the face of the part, how far up are we going to grab with the sub spindle? In this case, 0.9 inches. Click OK. And go ahead to simulation and click play. There's the pick off, and there's our synchronous work. You can click Show Finished Part. There's our finished part. Looks good. Go ahead and generate my G code. And I'll just save it off. And here's my 2-channel Swiss program.